That's actually an okay one.
I mean, that works. That works.
Yeah. However, if we probably a little better.
Yeah, probably
Yeah.
a little more.
Yeah. There we go.
But it's still
Yeah, it's still weird.
weird.
Well, no,
It's not
that
bad.
all right. Welcome, welcome. Nice to see some new faces as well as some old. Well, nothing meaning former, no, whatever. It's nice to see people here. Anyways, welcome, welcome. My name is Paul McKay. Those that are here the first time, we have this every third Tuesday of every month. If we don't, usually like December and those type of things. We'd love to have local presenters such as we're gonna have tonight, as well as those that we can find online. And we usually have some pretty good content. I always open up for what's happening, little water cooling, how things are going, jobs, who's doing what have you really learned, what's happening? Anything happening? All right. I remember I'm reading. I get watched it too. We were talking outside about remote stuff. All right, anything else? All right,
We are thinking about doing once or twice a month hack night kind of thing.
cool.
Basically a meetup for working on open source projects, talking about architecture. We have whiteboard at the Forge meet space. We'd just be meeting there and just kind of doing stuff and talking about whatever is relevant and just pretty cool hanging out. If there's interest in that, reach out to me and find out.
So he mentioned the word Forge. What Forge is a community of meetups. And we have the Go meetup, this meetup. I think there's I don't know if the machine learning is still going.
It is ML ops, but yeah.
ML ops, we have a leadership meeting. We have a,
The ML ops is tomorrow.
yeah, tomorrow. So if you want to join a great community of engineers and others, it's Forge Utah. I think it's out on the meetup site, how to sign up, but if not, just let me know afterwards and I'll send it to you. There's a lot of different channels, a lot of discussions. There's a job board or channel to kind of see what people are doing. Anyways, it's a very lively bunch. And I encourage you to attend, and that sounds like a fun event to do. So when he said, huh?
We'll reach out afterwards.
Yeah. So when he's talking about the Forge site is there's another location in
123rd.
It's 123rd.
123rd and 20,
So
whatever.
um,
Right by Goodwood.
Yeah.
That whole
Yeah.
center.
so that's another location where we have meetups at times. Anyways, welcome. Good to have you all here. Tonight, good friend and also colleague, Pete. He's been on the DevX team, a developer experience team for how many years now? 4?
Coming up on 2 years since I started.
2 years.
Yeah.
Okay. That
I
was
started at Weave.
Oh, good to have him here. Our DevX team at Weave has done a lot. Carson's part of that as well, who's really created an incredible developer experience for everyone. And Pete's going to talk about some interesting things that they have done and helped us with on the Kubernetes side, although it's going to be more general, but applies to Kubernetes. So he said, ask questions during, after. Try to monitor the chat for those that are online. Let me know if you have an immediate question, and I'll try to raise that and ask that. Anyways, time's up to yours. Thank you.
All right. Okay. So like Paul said,
I'm Pete Krukenberg. I've worked here coming up on 2 years, and I started on the developer experience team. And part of what I'm going to share tonight is one of the projects that I worked on late last year and finished up early this year. And I'm calling it do-it-yourself service mesh, but really this talk is not about service meshes. This is actually about how you don't have to use a service mesh to do the thing that you normally have to use a service mesh for. So we will actually use a service mesh, but not one like you've thought of. So the reason why I'm here tonight actually starts with this message that Derek's not here, is he? Yeah, then I can say what I did. We posted this on one of the Forge Utah Slack channels about how painful service meshes are in general. I don't think that Istio stands out to be any particularly worse than any other one, and requires you to shoot yourself in the foot. So I'm kind of curious. I've actually never had the privilege of having to run a service mesh. Have any of you gotten to do that? Yeah, so tell me about some of the pain points with running a service mesh.
Today was someone that has 7 different proxies in a request chain. Something was broken in all 7 of them.
Okay. That sounds very painful. All right, what else? What other kind of problems are painful with service meshes?
He's talking about generally it can be very difficult to troubleshoot. It's you feel like you got it, and then you realize you have no clue. And when it works sometimes. And then when it doesn't, it really doesn't work.
I think it just gets rid of all of the observability that I know and love and makes everything in my world more complicated and doesn't really give me any value. And I've done it with 4 different service meshes now and still.
Same problem, yeah. So the way that I got into this is we were trying to solve these problems. So I had heard a little bit about some of the things that we were trying to do with service meshes. And the main one really was this enable canary deployments for our deployment pipeline. I don't really know a lot of the history. The main thing that I kept hearing was we would have deploys that would go weird in our dev environment. And the first question that would pop up is this related to that weird CNI problem with what was this V? And so eventually we ended up deciding we just couldn't use it. I think we looked at Istio, managed Istio for a little bit. And I started kind of poking around at this. My introduction to what a service mesh does came from this project. So these were the things we were trying to do. We were trying to figure out how to support ephemeral deploys to be able to do, rather than having a staging environment, we just have essentially our dev environment and then our production environment. And if you want to test something in a real world environment, you deploy it as an ephemeral into our production environment. And then you can test it in kind of the exact same environment it's going to get deployed in. And then kind of as a side effect of this last one wasn't really the intended purpose, but I don't know if you have this kind of stuff going on in your clusters, but we had this, even though we have this microservice environment that's supposed to be decoupled and allow each team to work independently, we had these very fragile dependencies between teams that essentially meant if you were the team serving clients, you had to coordinate with all of the people using your service to make sure that they updated this. So you had to do this whole kind of deprecation and whatever. So that looked like maybe a cool thing we could solve with this. So just in case you don't know what a canary deployment is, this is kind of the idea is instead of doing deploys and hoping that nothing breaks, you can deploy a new candidate, have it tested with a percentage of the traffic. If it doesn't have problems, then it gets promoted to be the new deploy. Okay, so how do we do this? So what we want to be able to do, I'm going to just follow kind of two different paths here. Let's say that we have a HTTP. There are different ways that we could follow this path, but I'm going to just start with, say that we have an HTTP request going to service A, and we mark it as we want it to go to the ephemeral instances. In our case, we deploy those using the branch name. So we wanted to be able to test out how this request works if it hits these ephemeral deployments we've done. So Traefik takes care of the HTTP part, routing that to the correct ephemeral test service. And I'm jumping over a lot of under the hood kind of stuff here, but I don't think that's super important to the points I'm trying to make in this presentation. And then service A, what we want to have happen is that it would then continue with the gRPC request, and we want it somehow to be flagged with this test thing. So we're going to stick that into the gRPC metadata, basically a header. And what we want to have happen is that when it makes this request and change it through service B, service C, service D, if there are any test ephemeral deployments, we want it to hit those. If there aren't, we still want it to work. We want it to hit the non-ephemeral deployment, so the standard deployment. So the idea with this is I want to be able to see what happens when I make these changes. I'm going to do these the test deploys for the specific service that I care about, but otherwise I want it to just work normally. And then I can fiddle around with those ephemeral deployments and tweak them until I get it to work just right. Then of course, normal requests would have no header. They would just go through all of the non-ephemeral deployments. So that's what we're trying to do. This actually covers both of our requirements in terms of supporting ephemeral deployments, obviously, but a canary deployment is just one of these. And once we do a bunch of testing with a percentage of the traffic, then we just turn that from an ephemeral into a non-ephemeral. So this kind of solution solves both of our problems. Okay, so just to put that a different way, we could describe that as a route map. So like if I'm trying to get to service A and I'm trying to get to the test branch ephemeral, I want it to go to this thing. And I'm going to describe the non-ephemeral as the default. So that's kind of that case where I don't want to jump back to this. Yeah, so the problem here, the reason why we didn't go through this is ephemeral on the foo branch. So I need to have that default so I can say, hey, if there's no test ephemeral, go to this thing as kind of the last resort. So that's what I've got there. You know, that's my be the default for service C. Okay, so let's say that we have that route map, and what we want is we want service A to be able to connect to service B, and we would like something to be here. We can't use our hard-coded environment variables because those only point at one thing. So how do we make, what do we have here that makes service A connect to, it should be the service B ephemeral? Well, that would be a service mesh. Traditionally, and that's what we're gonna kind of use here. So in a service mesh, what we would have is a service A would have, and there are different ways service meshes work, but pretty common one is they have a proxy sidecar. So that gRPC request actually hits the proxy sidecar, and then it knows about that route map that we were looking at, and so it knows to send it over to service B, the test ephemeral. And Envoy is an example of this. What I built is based on some of Envoy's work. And they have this service called XDS that would generate that route map and send it to the proxy. So it turns out that there is inside your gRPC client. Oh, wait, before we get to that. So two downsides to this. One is that proxying those gRPC requests adds latency. It's not a ton, but if you're doing a lot of these, typically inside of a cluster, those requests are very fast. It also increases the CPU impact. So like the number of requests you can process per unit of CPU is about 3 times lower, I guess it has a higher impact. It takes 3 times more CPU to process this. Okay, so inside of your gRPC client, and I know that this applies, we use Go, so I know that it applies there, but it also applies to Java and maybe some of the other implementations. There is actually a little XDS proxy, just like this picture here, that works exactly the same way. So it can receive that route map from your service mesh or anything that speaks XDS and work exactly the same way. This obviously has the upsides of there's no latency, or whatever latency is very minimal. It's just has to be up in its local cache of that route map. And CPU should be roughly the same. And if you already have a service mesh, like the reason why people use this is to get the better performance. So our question was, we didn't have a service mesh. We didn't have a reason to have a service mesh other than to solve this specific problem with gRPC. Could we do something here other than install one of these horrible service meshes? So it turns out that Envoy has this project called Go Control Plane, which is an implementation of that XDS service. It's basically the same thing that they build into their product, the data plane API, which is in C++, but it's in Go. So that's pretty easy for us to work with because we already have expertise in Go. So I'm going to hop into the project real quick just to show you the code is actually pretty approachable. And I need to share this tab. Okay, so Go Control Plane. The first thing I'm going to point out is it's got a pretty nice README that includes this little link here that talks about an example server. And essentially, I started with just using their example server and figuring out how do I make it do the thing that I want. At least with Envoy, there's a lot of documentation. I actually found it a little bit hard to, like the data structures that they have, I think maybe are very obvious once you've used a service mesh quite a bit. For me, having this introduction, it wasn't super obvious. So I found that just using their code was a pretty good place to start. The thing that I would like to, so I've got a little thing here that you could stand up and run yourself pretty easily. I want to jump into this, because this what they call the resource is essentially a description, how we're going to describe our route map. So for example, here's how they describe an endpoint and gives you some idea of kind of the complexity of their data structure, how many different things relate to other things. And I want to drill into this. Yeah, this right here. So we're going to describe 2 things in this. One is, well, 3 things, I guess. We're going to have kind of a, I think they call it a node. So we want to be able to say, I want to connect to service B. So that's going to be what I think they call a node. We're going to have an endpoint, which is going to be the host plus the port number. And then we need to be able to add some matchers. So they've got this way that you can specify, kind of like with a load balancer, match on this URL on whether it contains this string, whether it's on this port. So we're going to match on, the things we need to match on are pretty simple. We're going to have to put in something kind of like this prefix. We'll always match on the root prefix. And then sometimes we're going to have to match on that header. So whether it's an ephemeral, on an ephemeral branch or not. That's all the code I'm going to show. Well, actually, I'll show a little bit more. But so I definitely encourage you, kind of as a follow-up, if you want to see how to get started with this, that's a good place to start. All right. Okay, so how do we take this and we have to implement two things. One is the route map that goes into the control plane. And then the other is we need to probably do something different with how the gRPC clients connect. Up to this point, without using a service mesh, we connect to essentially the host name and port number. So we're going to take this route map, and this is what I would suggest is the thing that we started with. I'm going to show you kind of what we ended up with. But the first pass we did was actually to just put that in a YAML file. And even if you don't do more than that, the benefit of having all of your definitions of what talks to what or what's available to be connected to in a central place, stick that into a GitHub repo, and then you've got a way that people can update that without conflicting with each other and see kind of the complete definition of these are all the services and the ports that they provide gRPC on. Maybe a little tricky with this ephemeral thing. You might not want to do that with PRs, but maybe you stick that somewhere that can update those a little bit more dynamically. But that would be like a good first pass at doing something that gives a lot of the benefits of what we ultimately end up building. Okay, and then on the client side, there's two things. One is to tell the gRPC client to use XDS. You have to add this environment variable, and there's two ways to do it. We actually do this as we embed the JSON in the environment variable because we actually stick it into Big Map and Kubernetes, so it gets loaded when any pod starts up. Most often, like when you look at the repo, they'll actually show this as just gRPC XDS bootstrap and then pointed at a JSON file. So playing around with it in your own environment, that might make more sense. And then what we're gonna change with how we connect to gRPC, this is the same call that you would make in Go. I think it looks somewhat similar to this in Java. But instead of connecting to like service b.svc.cluster.local, we're going to put this little schema in front of it and the name of the thing that we put in our route map back here. And then this thing here basically tells the gRPC client, like the XDS support, we'll connect to this thing. And the connection that it creates is a WebSocket connection. So it's getting constant updates. I did some playing around with this. The delay from when you make an update to the route map to when you can use it on the client is pretty short. There's probably a race condition in there somewhere. But so you point this at the XDS server, and then this thing can do the lookup, including the port number. So that makes it pretty simple for people to know how to connect on the client side. If you were doing an ephemeral connection, you have to do a little bit more. This is basically showing the steps that you would need to do to add that ephemeral header that triggers that batching rule that says send this over to the ephemeral instance instead of the non-ephemeral instance. We actually wrap this inside of a library. Actually, we wrap a lot of this inside of several libraries. So we have a little thing that we just have a little helper where you can say like add this, add the ephemeral branch to the header, and you don't have to put all the stuff in your code. Okay, so that solves two of our problems. What do we do about the canary deploys? So what we want to be able to do with the canary deploys is not just route traffic if it's got that branch header. We want to be able to send 10% of the traffic to the ephemeral instance and then maybe increase it to 20 or whatever. So one of the matchers you can add is a weight. So what we do is we set the ephemeral to like 10%, and then the rest of it would be going to the non-ephemeral. And then we can add, technically you could adjust that. We didn't end up doing that with our deployment, our canary deployments. We just do 10%. And That's as long as we want to wait. All right, so that covers all of our all of our problems. Before I go into kind of the rest of what we did to implement, questions on what I've covered so far, or things that maybe you want to drill into a little bit more than I did. Yeah.
So traditionally, service meshes are also meant, well, they can do authorization between services as well.
Yeah.
And they also, then there are other solutions for service discovery. You know, this sort of thing as well. And then for canaries, you have API gateways or other type of things that, or even ingress controllers that do those quite well. You have telepresence, which does kind of that local development and then has your ability to actually get route traffic with inside the cluster, which you could do a pseudo canary or whatever. It looks like you've built a lot to do this. Is there some reason why you wouldn't use other technologies that are already out there or?
Yeah, I'm curious what you say, but one of the reasons why I think we went this way, I'll actually show in the way that we can tie it into some of our other tooling worked very nicely. And to be honest, it was a solution that worked. And so I think we kind of just went that direction, but I'm curious what you have to say about that. Greg.
Yeah, so no, without nitpicking on specific things you're pointing out there, because some of those things I don't know if they solve the same problem. You're right.
Maybe not.
Let's start with the kind of the obvious part here is service meshes do a lot more than this.
Yeah.
Yeah. That's part of the problem. Service meshes do service identity, so they need an identity system. Service meshes do automatic, like distributed tracing, distributed metrics. We already had all of that. Like, so every service mesh we looked at, including Linkerd, which is great. Though it's the most lightweight service mesh that I've ever used, still had this massive control plane that when we started actually ramping it up in our development cluster, our smallest cluster, started falling apart really quickly. We had become experts in the Linkerd control plane to keep it running. And we're doing all of this, like, look at all of this laundry list of things the service mesh solves. What do we need? We need percentage-based load balancing and some metadata-based routing. Like, those are the two actual, and then we ended up getting the service discovery for free, and that was nice, but that wasn't the intention. We're like, all of this is just so that when one gRPC service calls another one, they route down the line through, based on the metadata, you route to a separate deploy that's a branch of code. So this whole thing is just built because we actually wanted these two tiny pieces out of the entire service mesh scheme. And we didn't need we don't actually need the part where, all of your network connections go through the proxy. Like, you don't have to change your code. Like, we didn't, all the big benefits are stuff that we're like, we can just change our code. Like, we have Go, we're fine with updating the code and making some changes. We don't need everything to go through the proxy.
Yeah, and I think we didn't have to send anybody to be trained on any of those things. We don't have to have anybody manage any of those things. In fact, in some ways, because we could tie this into some of our other tooling, particularly Kubernetes, this is essentially like GitOps for service mesh. And I know that I'm assuming that most service meshes you can manage in a GitOps sort of way. But this actually ties very nicely into all of our other GitOps stuff. But the amount of config the team has to do is essentially 2 lines.
Yeah. Well, the overhead of this, so the overhead of doing service mesh this way really is light. You have a control plane server that serves up a route map, and you put an environment variable on your services. There's nothing else you're running. And if the control plane server goes down, then you can't make changes. But there's no extra databases. There's no extra laundry list of things. It's just.
Well, what you described though, service mesh is a huge term.
It is.
What you described was you don't have to be a service mesh to do service discovery.
Correct. Or to do database
Right.
routing, to do.
Right. So that's my question is that this isn't a service mesh. It's not even compared to a service mesh in the sense that it has attributes that one could define a service mesh to have some of those. But I guess the thing that you talked about, the problems to solve, what were the priority of those things? And what you're saying is, it sounds like existing tooling was kind of that sub priority, which it fits well. But I mean, like the canary deploy, if that was a big one, there are a lot of other different ways to do that as well.
Yeah.
But which of the three that you mentioned were, or were they all together a priority?
Well, we really wanted to do, basically to deploy a version of code, like a second instance of code. So you have your main, this is I think that we kind of didn't maybe cover what an ephemeral is, because it's sort of an internal term to us. An ephemeral deploy is you have your code running out there live, whether it's in dev or prod, doesn't matter. And you have a new version that you would like to put into that and start up, but not route traffic to it. So here's my new branch. I'm going to stick it in dev. Nothing's going to go to it yet, except for the times I call to it with a specific header. It says, my intention is to go through the front door like I normally would, except for route me to that, which is easy to do in HTTP land.
Yeah. But
But gRPC is harder, right?
So it's a smoke deployment basically is what it is.
It's sort of, yeah, exactly. Yeah, in fact, I don't think Linkerd support, maybe now it does. For a long time, it didn't support gRPC metadata based routing at all. It was really like, we support gRPC, but if you want to like go to one of two endpoints based on some metadata in gRPC, we just don't do it.
Yeah, I think the other thing is this realization that a service mesh, as far as gRPC goes, really is just driving the route map that's inside the gRPC client. Because whatever benefits, and the gRPC client doesn't cover everything that a service mesh could normally do. They prioritize development, and most of this has been driven by Google to support their traffic director, which gave us some confidence that somebody was like finding the bugs in this before we did. But they're driving it more around the use cases in the real world for using gRPC in the way that we're trying to do it. And so really the trade-off is more about, do I want these extra benefits, whatever they might be, of a service mesh at the cost of the proxy in gRPC? Or do I just need what's built into the gRPC client that is high performant? And in our case, that's what we needed. And in that case, essentially, there's almost no value in the service mesh because it's just doing the same thing that we're now doing. And I think if that,
you're already running a proxy in process, right?
Well, the gRPC client's essentially just super smart and does the proxy stuff.
yeah, but so the interesting thing there is rather than it proxying, it's just saying like, instead of going and doing the DNS lookup, it's just looking in its internal. In some ways, it actually might be more performant than it is under normal circumstances because it's got the complete information about how to connect internally.
I guess just one last thing, just for some that service meshes aren't bad. Yeah, let's not. They're not. Well,
They're not morally wrong.
what I'm trying to say is that because it's so broad, there may be cases in which you're not talking about here that a service mesh that people want that other type of capabilities that service mesh does provide, right? The authorization stuff,
Well, what this doesn't have at all.
traffic control, QoS, there's a bunch of stuff that we didn't care about, you didn't care about. So I just want to say that there may be a need for a service mesh.
Yep.
Well, let's put even this only works at Weave because service to service communication is over gRPC.
Yeah.
There's no HTTP answer in this entire presentation, right? We're like service mesh.
Yeah.
If you're doing 100% gRPC, like, and we have to have, in fact, a separate solution for some of these same kind of things, and we do it at the ingress level.
Correct.
For HTTP, right? We just say like services, and Google does this, right? Isn't everything like Google gRPC like everywhere?
XDS is the way that pretty much everything is programmed nowadays, even in other meshes, we're starting to see XDS become the standard. Envoy is often the data plane, but gRPC, proxyless gRPC is a pretty close second in terms of if you live in that world and can live with a subset of features. very capable way of programming clients. It's actually interesting here. So you don't even have the actual endpoints. It's still hitting the Kubernetes service discovery to find the actual pods, right? Because you're programming Kubernetes services as the targets.
There's no routing.
Yeah, so like typically this is like the headless address. So it effectively is doing the same thing that we were doing before with our hard-coded environment variables. Just getting that to a place where, because one benefit of this is so that scenario before where a team wants to move a gRPC service from one service to another, they can actually move that without any clients being affected because the gRPC client that has like this proxy capability built into it will pick up that change and shut down, like stop traffic from going to the existing connections to the old service, and then start up connections to the new service and move them over there. So it actually allows for a lot more flexibility in moving stuff around. That doesn't happen that often, but it's nice to have it. Yes.
Question, sorry, I was just curious, I'm piecing it together in my mind and I've not used any of these things, but you have the XDS server that is being reached out to.
Yeah.
But the config that describes where the services are, or how to like connect to those services, that is used by XDS, like the XDS service. But if somebody were, like a team were to stand up a new branch, what's the developer experience or the tooling in place to update the config so the XDS service knows the new
And
branches?
that's why we're presenting it here, because that's where Kubernetes comes in.
Yes, I think the YAML files are sort of like, you could do this with, it's just this big complicated, you saw how complicated that struct is. And so you choose your own abstraction, you minimize it, take your trade-offs and get some like sort of simple config. And you could do it just a YAML file and a server that a YAML makes a big complicated struct out of it, following your convention. But I think your next thing is like, how do you do that at scale?
Yeah, I wanted to present this because I wanted to at least attempt to show you kind of how this thing works standalone. Because part of the challenge here, and really I think the question is like, I'm going to show you how we implemented it. And I wanted to be able to separate, here's the core pieces, here's how we apply those pieces. So you can maybe figure out like what pieces would we tie it into in our environment. Okay, I think there was another question.
I was just curious, like how to go from like your old config to that route map, like how painful was it, or like what was the process to come up with
Migration, yeah.
Yeah, pretty trivial. So
Okay.
what we ended up doing, we have generated code that makes this work very nicely. So we had kind of a library wrapper that wrapped around gRPC kind of stuff before. And we which used the environment variables, and you had to kind of configure a lot of stuff yourself. We added a new method to that library that I'll show you in the later slides. And we just told teams, hey, start using this new thing. Here's how it's so nice for you. You can get rid of all this stuff. And you have to be done by, I think I said September 1st. I think pretty much everyone switched over. I haven't actually gone back and checked everything, but most teams, it was so trivial to make that change that they just fit it into their regular workflow. So because we wrapped it like that, worked pretty nicely. If we didn't do that, then the change would be also pretty trivial. I can't remember where I think there's a later slide here. So the change that a team would have to do is just to this. So where they previously, had like the full host name and port number, they would just make that string replacement. And even without having, like we've got a whole system that we tied into, you could still have generated code that took this thing here and generated some libraries that people could. There was actually, we had kind of an earlier implementation of this where we had code that people could hard code this stuff in. It still had some of the same problems, but it allowed teams to not have to think about how they connect to the right server. So you could do something kind of like that, even with this very simple approach. All right, other questions before I reveal the way that we implemented this? And you can ask questions, we can go back to this later. Okay. So this is the original stuff here that we were talking about. And we actually call this schema control plane because we have a system. Are any of you familiar with protobuf? That's probably the most common way to do a gRPC implementation. So Buf is a system that lets you generate code and some other nice stuff from protobuf files. And so we use that to generate the Go code that then teams can use to work with gRPC and as well as the RPC services. And then we also have, you may have heard about the infamous Weave YAML. So we use that. There's now kind of an industry standard called SCORE. Ours is a little bit more concise than that, but it's kind of this idea of defining, I guess it'd be kind of the evolution of Docker Compose files. A little bit more of a declarative thing to define your resources and how to do your deployments. So we take those two things and feed them into what we call the Weave deployer. And essentially what the Weave deployer does is generate Kubernetes manifests. And so those go to Kubernetes. So we use these things to define that route map and to define how to connect to it. And then this is the same Go control plane here. We have a Kubernetes watcher that watches for things as they get deployed. So I think to your question, like when a team deploys something with a new branch, we would actually pick that up here, and that's how we know to add that route for that branch. And then the other thing is, and I'll show this on our very last slide, we actually export that route map out to a GCS bucket so that we can pick it up with other resources outside of the cluster if we need to. So we have a couple things that we do here. One I'm going to show a little bit later. The other one is sometimes, particularly during migrations, one of the things teams had to find out is, I want to be able to connect to this service. Is that service actually in the route map? And so we have a tool that they can look for information on a gRPC schema and find out what services are hosting that in the route map. Okay, so here's how we handle a gRPC server. So in our WAML, this is what somebody has to enter. So they basically just say, this is the example protobuf that I want to be able to offer to services to connect to. And that combination of the WAML with the deployer generates these annotations. So we've got here's the schema name. So this lets me generate the route map, and I can get from Kubernetes which service I am, because this is a service file. So I can get the host name from that. I can get the port name from here. I can get the name of the gRPC service we're going to connect to. I kind of combined a few different things together that don't always look this way, but here's how we do our canary. So we have another annotation that lets us set that weight. And here's where we put the ephemeral branch if we have one. And then there are a couple other things here that we use for the watcher to know what kind of resources to pick up. So that generates the route map. And the only thing that teams have to do to drive it is this. The other side then, how do we connect from a client? So this is actually what a team would put into their code. And they actually can call that schema, that protobuf schema, by the same name that they're familiar with. And then they just say, I want a new schema client, and they pass it, and you pass it a context. And they can do that because Buf generates this code. So it basically just wraps, there's a bunch more that goes on here, but essentially it just wraps the gRPC instantiator or connector and adds in this XDS schema thing. So this was the thing that teams had to implement. They used to do example.newClient, and all they had to go in and do is go in and find all the places where it said example.newClient and change it to new schema client. And then they were switched over to the new system. And this here is part of the, when this code is generated, it's able to extract this name from where that protobuf is stored in our protobuf repo. So we have kind of a standard way of naming things based on where you put them into the schema repo. Okay, and then the last thing, so we have a tool called BART that we use for a lot of our developer experience. That's how they do deploys. They can look up information on builds, all sorts of other things. And one of the things it supports is running stuff locally. So it'll like start up the service and set up the right things to be able to run the service. So we added to that a way that you could specify, kind of similar to this. It has like a config file. You could say, when you run this, set up these connections to remote services using the XDS. And so from a developer perspective, they just do BART run. And what that does is it actually starts an XDS service on their machine. So this is something that I think might be pretty hard to do with an actual service mesh. But that Go control plane is such a small thing and it's Go code, so we could put it right into our BART program, which is also Go. So we start up a little XDS service on their machine. It connects to that GCS bucket and gets the route map. It then creates a local route map where it routes things over a port forward connection. So it sets up the port forwards, takes that route map, essentially changes the host to the local host that points to that port forward. And that's how you set up port forwards to connect to remote gRPC services without them having to do any kind of changes to the environment variables to point them to local host or anything like that. So this concept here, I think, is actually one of the, like, we've got a few other things we are exploring with this, like integrating this into some of our test frameworks, so that new schema client also works when you stand up like a mock server, and it'll just kind of seamlessly send it to that mock server you got running locally. Yes.
So this stitches up the networking that way to other services inside. How do the services talk back to you locally?
They don't.
Okay. So it doesn't solve what, like,
It's not a telepresence.
telepresence or whatever that thing is called.
Thank you.
So, yeah, what this same framework is used. You sort of already know this, but like the same, you're right. This is a one way. This is I'm going to talk out to X, Y, and Z things that are dependencies of mine that I need to in order to serve my requests. And I would like to reach I'm developing locally. I don't have any connection to anything, but I would like to, when I talk to the user service, I want to actually talk to the user service wherever it lives in the dev cluster. Like just, I'm going to connect to it the same way, it's the same code in locally or when it's deployed, but just magically plumb just my user service to the user service in the dev cluster, or the dev environment. Magically plumb the next service to that same one. And you're rather than trying to do a telepresence kind of full network swap, which every time I try to do that at scale is really hard because you have to have like a million little deploys. Telepresence is like, make a deploy and we'll put you in, and it takes a lot to set up. But this is just like piecemeal poking. And you're right. If you want to test, like, I'm going to run some code, have somebody else where I'm downstream of the dependency, that's not really enabled for local dev at all.
Right.
We have other mechanisms where you use the same thing to be able to, all that header-based routing allows you to deploy it ephemerally, hit that end, hit the top end of the pipeline, say, go to my branch, and then eventually get there. It's not as iterative as local development, but you can test that way with these same tools.
Yeah, so I think this, like our BART run kind of solves the problem. Same problem as doing like dev clusters. That seems to be like the new thing now, that you can deploy your entire environment into the cloud just for one developer. we can do something similar to that by between the ephemerals that a developer can control and then running stuff locally. And that could, like locally, they could also run any Docker containers. So I think really the benefit of a lot of times of running something locally is that they can put a debugger on it. And so they can step through certain things while they're hitting stuff ephemerally in the cloud or hitting the production instances in the cloud or dev instances. Yeah.
So is this always a single service, or if I'm working on 3 services locally, can I update XDS? Say, here's my local version of this, here's my local version of that, go find all the rest in the dev environment?
So right now, I think we just run one service. I mean,
So Bart run, there's no config here because the config all lives in a file in the repo. It says when I Bart run, and there's a billion options there, but when I Bart run, this is what it means. And you outline, I want you as part of, before you run my code, I want you to set up this, this, and this port forward. And so what you would do is you would say, set up service 1, 2, and 3 is like forwards. And if you have other local ones where I have a copy of this other dependency, you just wouldn't set up that forward. And you do a different Bart run config that says, point me over here.
Nice. I don't think I've ever seen anybody get features that would usually be service mesh into a local test framework outside of like Kubernetes service discovery. It gives you at a distance some of the same, like, hey, I want database.
Yeah.
Give me database, and then doing like K3S style local dev.
We all got sort of trained on that with when Docker, right? Docker came out and gave us network links between things, and like you connect a database by calling a database, and then we extended it to Kubernetes, and we do the same abstractions here, but it's often more like repo.
Well, it's one more layer on top of what Kubernetes was already giving you.
Yeah.
You could do it through on the service that has the
External services. So you can do canaries natively in Kubernetes, but it's only on a pod ratio.
Right.
So you can have 1 canary pod and 4 normal and get a 20% 1-to-4. But this does the same thing on a per request because it's on the client.
I'm trying to think, there was somebody that actually not per request.
just per request.
Yes, this is per request. It's so per gRPC session, gRPC can do streams, and so it's per initiating stream to.
So it's not per, okay.
It is
They're actually,
every time you say, I want X, it looks up the list and says, I've been told I should give weight of this to the first canary part and a weight of that to the other part, and it locally will decide, I've sent one this way and none that way, so now I'm gonna try the other side until the weights even up on its local.
yeah, and because it's actually in line with the gRPC, like it's handling the gRPC request. It can actually, it knows about each request, even though they're all going over the same connections.
That's
Basically,
the only reason we have Linkerd as a proxy at all in any of their stuff, because of that problem where gRPC TCP connections never turn out.
Yeah, it's actually, so my first pass at this, I didn't know about this capability in the gRPC client. It was pretty new at the time that I first started looking at this. And so I spent a bunch of time looking through all this code in the gRPC Go. It's got some pretty sophisticated load balancing capabilities, as well as some of the other stuff that we talked about. One thing I was going to mention is, so we didn't talk about some of the observability stuff that you would get from a service mesh. That's also built in. There's at least for Go, and I'm assuming Java would have something similar. There's a library called Channel Z that gives you tons of visibility, like all of these connections that it's maintaining to different services. You can see the state of all of those. It gives you all sorts of metrics on success and fail and so forth. So we probably won't end up having to put that into the XDS server. We'll add that into our libraries that wrap the gRPC client.
to your point, it was really cool the first time. So the very first version of this was run a statically configured XDS server and have a server and a client, right? And you have 2 instances of the server, one on port 1 and one on port 2. It's not that, but you get the idea. And you start up the client and it has static configuration from the XDS server that says, when you talk to the server, go to port 1. And you start the client up and make one connection, start hello worlding and just getting back the name of the server. And then you do whatever, you flick the switch on the XDS server to say, don't connect to port 1 now, connect to port 2. Right, like the most bare minimum local everything.
Yeah.
And that client just went, whoop, no reconnection, like the very next get hello world printed out server port, like the
Or I
other.
had to reconnect.
Yes.
It does, but you,
Like, don't mind me.
it's connecting, but I'm saying like your code says connect, start doing work. The reconnect happened, but you don't have to, there's nothing you program in to say the configuration change, shut down like that's all done.
The gRPC client has
The
code in it.
proxy, it does all that proxy.
It has built-in load balancing code so that it will do the same connection pooling you're offloading to a sidecar right now. It actually has most of the same features. There are some that it can't do because it just requires an inline proxy.
Caveat, no, the client can do load balancing, but if you want to not have clients do load balancing, you still do need something over here, which is why we care. Otherwise, we just do it in client, but
Well, the thing is that it actually, so even if you're not using XDS, the way that it manages, if you got anything with more than one connection, so if you're connecting to the headless, it'll stand up multiple connections, monitor the health on each one of those. It has a default load balancer to round robin between them. So if you're using the gRPC client, most likely you're already getting some of these benefits.
Yeah, I was thinking the one thing you don't get, so outlier detection is built in as well. So like if one of your targets starts returning errors back, that the load balancing on the client side is smart enough to say, hey, this guy's having problems, let me talk to a different one instead. But you're routing through the Kubernetes service discovery. And so you don't actually have distinct targets for the backend. And you're just relying on Kubernetes to update it fast enough to rip out
No,
the.
because the code there is massively simplified. The actual implementation of the control plane is watching
Actual pods.
well endpoints.
So in that case, you should set up a pod where you can force it to have like continual errors and watch how quickly it gets removed on the set. Because you're no longer relying on Kubernetes updating the service endpoints if you're not using it. In the example, it just had
Yeah,
the Kubernetes endpoint and you're working with either IP table rule updates or eBPF if you're on a more advanced data plane. That's the thing that's getting you to a target. Most of the time, service meshes do go directly to the backends. It's directly to the individual pods, and it's now on your client to be able to detect there's a problem and rip it out. You actually have control over those settings too, and like when it should keep it in, how long it should wait. And that is one of the failure characteristics that you want to make sure you're aware of how it's working. Because if it doesn't work well, you could have a bad pod, and now you're having to troubleshoot the hard problem of like, one thing's broken, where is it broken?
if you're reading your configuration Kubernetes endpoints and you have health probes, they will get taken out of the endpoint list, right? So like.
But like how quickly, like on the client side, you could say 2 requests, it's gone.
Sure, yeah.
You make it incredibly fast, way faster than you could ever do with DNS, way faster than you could ever do with a Kubernetes.
Health probes are on. So, yeah, so.
And most load balancers make extensive use of that feature. Where if they notice that, hey, I got 7 responses back from this one bad, especially because it could only be happening from that one location. If you have a load balancer in a different region and the pipe's broken, and it can talk to everybody else, but not one of the backends, it's the only one that needs to remove it. And so that has to be a local. And the other one is locality routing. So technically you could get locality routing if you get that information all the way down in your XDS as well. It's like these pods are in this zone. Hey, I'm in that zone. Let me prefer those so that you're not doing cross-zonal egress.
Yeah, we essentially have one zone right now. But yeah, I saw all those things.
We have lots of hosts, right? So we could prioritize
Good.
the node.
Yeah, the other thing that I learned,
Same host even, yeah. So like locality, I'm on the same host is.
Wow.
I also learned there's some built into the gRPC client is a health. Like if you have a certain endpoint, RPC endpoint in your service, it'll probe that for health. So you can actually have your service send back something other than, I think the default is just, is it giving an error code or not?
Yeah, I'm glad they finally did that because early on did not have that. And I remember you'd be talking to a bad pod or bad service, and you just keep on going. And you'd have to flush the whole cache, you'd have to bring down, because that gRPC was just saying, I don't know. I mean, you told me to go there and I'm just gonna keep on going. So I'm glad that they actually put that in later on, because it made gRPC pretty bad.
That was probably in there really early on. I'm gonna, like, some of our earliest problems were that we weren't using headless services. There was,
I'm talking 4 or 5 years ago.
oh, I see. Okay. Well, let me say this. I see this a lot with people when they combine gRPC with Kubernetes and are not using headless services, right? Because then gRPC has one endpoint to work with. And then you're surprised when it doesn't load balance. Like, it will load balance really well if you give it something to discover all of the endpoints.
Yeah.
So that's all I've got.
I have one more question.
Yeah.
What doesn't work with it? Because I've never seen a service mesh where it's just like perfect. Like,
This isn't a service mesh.
I won't call it a service mesh. It's indirection with observability and like it's load balancing at the edge. That is well within the ballpark of a service mesh. It's a very broad term, but I classify it. There's no way you made a perfect system that doesn't cause some pain somewhere else.
We haven't run into, that's actually been one of the surprising things. I fully expected as we rolled it out that we were going to find something that we had missed. The things that we mostly missed were around kind of testing scenarios. Essentially, and one of the things that we really had to force was because we have this very long established practice of hard coding addresses, we wanted to make it essentially impossible to do that. And so we've had to build some, in Go, you can do these kind of optional arguments. And so we've added some of those that allow people to do something other than connect to the XDS route map. And there, so far, I think we've got three use cases where it's connecting to the local host or maybe a specific pod. And yeah, it's actually been pretty amazing how well it's worked. So we've got, I actually did a count of this and I can't remember, but it's 100 and something clients that are using this right now and a handful that haven't switched over yet. So
That's not individual connections, right? That's like code bases.
yeah, like services that are acting as gRPC clients. Yeah, we've got, I think about 400
Or 90 something.
services. So
That's like 490 something.
Yeah, we're like close to 500. Yeah, I don't remember the scalability of the Go control plane, but I would expect to kind of keep up within that order of magnitude. Yeah, 2 zeros, you might have problems.
yeah, well, if it doesn't, like that gRPC bootstrap config, we can add in more. I mean, we could have, we have this whole thing running off of a single replica. And so we could add in multiple replicas for redundancy or for scaling. We
Have you tried killing that replica? What happens when it dies?
they cache it, so they keep working just fine until the service connects again. Or they would just,
Yeah, new clients are toast.
yeah, new clients would have a problem.
It's not the critical path,
Add a second replica, you define.
It's literally the critical path.
but for serving requests.
It's literally the critical, it's all of the critical paths.
I'm just saying, like,
Yeah, no, that's the other problem. So service mesh goes down, everything's down. Like your best case scenario is you serve stale, where like, hey, things that were already established and working, stay working. Otherwise, the entire, it's like you turned off networking, like.
what, and the advantage here is if that did happen, then you have certain gRPC requests that don't. A lot of the other stuff could potentially, like, you're not completely out because we're not sending literally everything through it, right? We're saying like,
Well, and knowing that you have fig in another location, like a bucket that like you could bootstrap yourself whole, saying, hey, I tried for 60 seconds, didn't get anything. Let me go call out to this, just grab a file. And like, you actually have a lot of outs on that, which is
Yeah, well,
not the case when you're running a really complex control plane, and like the circular dependencies and stuff that can get injected into that can cause tons and tons of problems.
Yeah, the fact that we could use Kubernetes as the source of truth for this, because it's very well, it's very mature in handling that kind of stuff. It also a lot easier to do.
Well, so how do you avoid the
Well, so you can still use the Kubernetes services directly, right? So like they added a layer on top of Kubernetes Service Discovery. That lower layer still exists, right? Like worst case scenario, you could redeploy, I guess you don't have the place to do it, but like if you could switch out all of those XDS endpoints for their Kubernetes equivalents, you're back to the place where you just didn't have the.
Yeah, if we were in a crunch mode, we could pretty easily use that sort of don't use this, but it exists override when you create the client that says ignore the XDS stuff and just connect to this IP address, which you always have for testing, right? You always have some sort of like, yeah, it's totally fancy. Don't even tell me where the server lives. I just know that you're trying to talk to this like generated code endpoint. So we're going to send you to wherever it lives right now. We could work around it.
But also you have the whole code base. Like you could just, if the Go code breaks, you can fix the Go code, which is.
I think the hardest part so far has been anytime you want to add a new feature, right? We have 2 feature sets on it, which is percentage-based traffic routing and metadata-based routing. Those are the only 2 things out of the entire XDS feature set we're using. And the trade-off is if we're like, we want to do another thing XDS can do, we have to learn the entire XDS document and data structures, and like we have to re-implement a bunch of stuff.
I've talked to 2 people so far that had very large teams running their own service meshes. And it was solely because they eventually got to the point that it was too much of a burden and they wanted to switch. But they were already using Envoy, they were already using XDS. And so it just became, hey, can your XDS do all of the things that my XDS is doing? And it makes the decision a little easier, but eventually there is that tipping point of like, how much do you want to maintain? If Go control plane had like a lot of churn on it, that would cause a lot of difficulty for you. I don't think it does. I think it's a pretty stable system. But now it's your adoption churn, and then like, hey, if you get to the point you're wanting to do MTLS and like a whole bunch of more fancy features, then
we would need something else. Yeah.
Something else. If you had the ability to do per request canaries in Kubernetes, so like a service resource, but a service resource that had traffic waiting.
That's gRPC aware.
It was gRPC aware, and like that would have probably solved
a lot of it, yeah.
a lot of, if not all, of the same problem.
I think if Linkerd would have worked, we never would have gone down this path.
Sure. That's also
Because this would have been an optimization.
So that leads to one of my questions here is what are all the things that you tried that didn't work while you're making this? Because this is what worked in the end. What are the things that you're like, oh, well, let's do this. Oh, that didn't work.
Yeah, well, I wasn't involved in the Linkerd stuff. That was going on when I showed up. I went down one path, which was trying to figure out how to use. I didn't know about the XGS support or any of this stuff. And so I discovered it while I was looking through the gRPC code, trying to figure out, like I knew it had this thing with DNS that you could set up custom resolvers. So that was kind of my first pass. Can I somehow make that resolver do what we want? And it was actually pretty frustrating because in Go, whoever builds the code can actually control whether you can access it or not. And all the cool stuff that I wanted was not accessible. And so I ended up reading a lot about kind of what this project was and why they were hiding stuff from people using.
being like public versus private
Internal.
configuration in the.
Yeah, so the way I discovered this was so I got to the point where I was actually thinking, maybe I just need to fork this so I can do what I want, and that's not a good option. So over Thanksgiving, I was working on a project and I thought, I'm gonna go see what this XDS thing is that I see in Go. And I came across this presentation that like described the whole thing, and I was like, that's what we're gonna do. And so I came back after Thanksgiving and started playing around with a control plane and built this. And it was one of those kind of things where, like, when you find somebody who's solved the problem in the way that you're trying to solve it, it just works. Where before it felt like we were really kind of going against the flow.
Yeah, I think so. DNS multi-A or SRB records is a way to try to control it all at the DNS layer, but it has no introspection into the connections. And so you get the like, hey, I connected here and I'm stuck here. Console does very close. So console has a data plane, but can do proxyless gRPC. So console could have been, if you had an existing deployment of it, you could have tapped into its service discovery and like catalog of services instead of sort of building your own. Although the one you built is probably easier to manage anyways, especially.
We use console too, and it
You
worked.
program XDS as well as anything else, so. And then, so traffic director is usually in our environment, how you would get an XDS control plane.
Traffic director was actually kind of our plan B. So if we had gotten into this and found out that Go control plane wasn't mature enough to do what we wanted, then that would have been one of the options that we could have tried. And I didn't know about the others. There was actually I think one of the things that made me very confident that this was the right path. I saw an early presentation from, I forget the guy's name that made Envoy. And the very first thing he made was the service discovery service, which is exactly this. And I was like, all that other stuff that they added later, route discovery, endpoint discovery, was all added after that. So I thought, okay, so if I'm trying to build the same thing that they did, this is probably the right.
He's launching another startup too. Observability, he's doing a whole nother mesh-based thing, but I'm pretty sure it's a data plane version.
And just to clarify, so the control plane language bindings, they're only available for Go and Java. Was the only two you mentioned? Are there any others?
Yeah, as far as like on the client side,
Yeah.
I know that they're available in both of those. I think Java is actually kind of the first class citizen in gRPC implementations.
It's all, right? So the whole thing is,
I learned that a little bit as I was going through this, because a lot of the work on this was done first in the Java client, and then, so there are a lot of references in the Go side saying, hey, let's do the same thing that's in this Java.
The Java people like this, I should not be here.
And if your gRPC client doesn't work, then you can almost just slap an Envoy sidecar next to it and have it take the XDS. And then if you're not using gRPC, that's what you had to do. But
I don't know about other clients. I would guess that if it's not there yet, it's going to be because it's not that problem of the performance impact when you don't have that proxy built in.
Any other questions? Any more answers?
XDS3 comes out. Stay on XDS2.
This is actually running on XCS3.
Yeah, so what about 1.4? So like those version comps are the ones that make things difficult too, but you can also.
I'm not on the DevX team anymore, so that's
Carson's problem.
somebody else's problem.
It doesn't have the same pain Kubernetes does, but there were folks on XDS1 that had to trudge their way to 2, and folks on 2 that have to trudge their way to 3. So.
That'll be a really interesting thing to solve.
But also, if you don't need it, like if nothing's going to get rid of the older versions, you have the whole code base and everything. You're not dependent on anything. So.
I would think that would be more by like we need some other capabilities. And so that'll be an awesome problem to have. All right. Oh, yeah.
Why was there a tool called Art?
Oh, that was before my time. Somebody really loved The Simpsons.
Okay.
That's for founding if every single service was named after a Simpsons character. And that's thankfully over now, but there are some that have got to keep the characters. And so Bart is a hangover from that. And what else are you gonna call it, right? Like, you gotta give it some sort of clever, catchy name that developers like. Calling it like a dev CLI is boring as hell, so that's why.
All right. Thank you very much. Thank you, everyone.
Do you have any of the same problems? Like, do you do canaries on your edge, or everything's gRPC and flushes all the way through?
No, so